Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are going to learn about eigenvalues and eigenvectors, but before that let us focus on what are the various properties of vector, that is inner product of the vector, norm of a vector, unit vector and orthogonal vector. So friends, very first and the basic and fundamental property of a vector is inner product of a vector. So if we consider any vector, so in this particular case we are going to consider column vectors. For example, if we have got x as, and the elements would be x1, x2 up to xn, and we have got y vector as column. So we have got y1, y2, y3 up to yn. So when I want to write this particular column vector as row vector, I simply write x transpose or simply x dash. So this vector becomes x1, x2 up to xn. Like that, y dash becomes y1, y2 up to yn. So in order to have the inner product of a vector, it is denoted by x comma y. Now in order to have the inner product of this vector, we are going to have corresponding elements, that is x1 into y1 plus x2 into y2 up to xn into yn. So let us take few examples, like x is equal to, let's say 1, 2 and 3, and y is equal to 3, 4 and 5. Therefore x dash is nothing but 1, 2, 3, and y dash is nothing but 3, 4 and 5. Now inner product is denoted by x comma y. So this is going to be 1 into 3. So the inner product could be first element into first element, that is 1 into 3, plus second element into second element, which is 2 into 4, plus 3 into 5, third element into third element. So we are going to have 1 into 3 plus 2 into 4 plus 3 into 5, which is going to be 3 plus 8 plus 15. So therefore inner product x comma y is going to be 3 plus 8, 11 plus 15, which is going to be 26. So 26 is the inner product of x comma y. Let us focus on second property of a vector, which is nothing but norm of a vector. Norm, or it is also called the length of the vector. Now length of the vector is not dependent on how many elements are present. It has nothing to do with the number of elements present in it. The norm or the length of the vector is nothing but the modulus or the magnitude of that particular vector. So in vector, let's say a bar, in vectors in physics we learn I bar plus z bar plus k bar. In that particular case we take the coefficients and we take the square of it, we add it and then take the square root. Just like that we are going to perform the same method over here. So let us consider and understand vectors norm. If we have got x as x1, x2, x3 up to xn, then norm of a vector or length of the vector is denoted by like this. Double mod of x is nothing but square root of addition of square of each and every element, which is x1 square plus x2 square up to xn square. This is nothing but the norm of a vector. Now very important. Now this is norm of the vector or length of the vector is nothing but the length. So it has to have some kind of unit. So even if we don't have any unit for length, we just write unit. For example, we have got x as 1, 2, 3, 4. Basic example. Therefore, norm of x is nothing but square root of 1 square plus 2 square plus 3 square plus 4 square. So nothing but this is square root of 1 plus 4, 3 square is 9 plus 16. So total we have got 16 plus 9, 25 plus 4 plus 1 is 30. Root 30 units. This is nothing but the norm of a vector or the length of a vector. Let's take an example to understand what is unit vector. So here I have got x as 1 by 5, 2 by 5, 3 by 5, 2 by 5 and again root 7 by 5. So let us take a mod of this. So mod or norm particularly of x is nothing but the square root of summation of all the squares. So 1 by 5 square plus 2 by 5 square plus 3 by 5 square plus 2 by 5 square plus root 7 by 5 square. So this is nothing but 1 by 5 square is 1 by 25 plus 2 by 5 is 4 upon 25 plus 3 by 5 is 9 by 25 plus 2 by 4 is 4 divided by 25 and root 7 by 5 is root 7 square is 7 and 5 square is 25. So 7 by 25. So if we add this, I'm going to get 25 plus 1 plus 4 plus 9 plus 4 plus 7. So if you add this, 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 4 is 18, 18 plus 7 is 25. So 25 by 25, which is going to be root 1 and it is going to be 1 unit. So I can say therefore x is an unit vector. So this is how unit vector works and this is what the concept of unit vector is. Now let us understand the next property of a vector, which is orthogonal vector. Now we have been given two vectors and if the inner product of two vectors are said to be 0, then we say these two vectors x and y are orthogonal vectors. So we have got x, let us take an example. We have got x as x1, x2 up to xn and y as y1, y2 up to yn. And if the inner product x comma y is nothing but x1 y1 plus x2 y2 plus up to xn yn, and if it comes out to be 0, then we say x and y are orthogonal vectors. Let us take an example. X is nothing but 1, 2 and 3 and y is nothing but -5, 1 and 1. Let's take an inner product. So x comma y, this is nothing but one corresponding element into corresponding element. So 1 into -5 plus 2 into 1 and plus 3 into 1. So we have got minus 5 plus 2 plus 3, and that is going to be 0. Therefore x and y are orthonormal, or we say orthogonal vectors. Since the inner product of x and y is going to be 0, therefore we say x and y are orthogonal vectors. So these four properties we have seen: inner product, norm of a vector, unit vector, and orthogonal vectors. Thanks for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.